Hello everybody, today we are going to talk about pointers. This topic is really very important and it might be at the beginning very confusing. And be like, hey, why do I need pointers? Don't worry, next lessons will show the usage of pointers. Look, right now we can create variables that can store numbers, strings, floating point numbers, but we still have one more value that we don't know how to store. This value is called address of variable. So when I have, for example, variable int var and it equals 5, that variable has an address that we can get by using the ampersand. The ampersand and after it the label of variable will give us as a result the address of variable, right? Okay. And now we need a variable that could store addresses. It is really a very important thing to know how to do that. You will notice the usage of something like that in next lesson, so don't worry. But right now we need to learn how to create something like that. And to create something like that, we are using the type that we want to point to, and then the asterisk, then the name of our variable, we call it p from pointer, and then the semicolon. This variable here can point, it means that it can store as a value the address of variable that the type is integer, okay? So for example, we can store that address here, right? We can do something like p equals address of variable. I can compile it, and as you can see, everything worked fine. Now we can send to the output, for example, p. And you will notice that both of the things the same, right? Both results are the same. So now we know how to store as a value address. So pointers are ordinary variables that can store address of variable, addresses of variables, right? Okay. Now let's see how to get a value, but just by having the address. So here we have an address and here we have an address, right? If I want to get the value under the address, I can use something like that. The asterisk sign. The star, right? Here I can do the same. And now you will notice that we got in both cases the same value. And now you might be a bit confused because here is asterisk and here is asterisk. The asterisk that is preceded by a type is used to just inform. That asterisk here is just used to inform about that this variable is a pointer. So it is a variable that can point to address of another variable, right? Okay. This asterisk here, that asterisk here, is used to retrieve, get value from indicated pointed area in our memory, so address, right? This guy here is not preceded by a type, okay? Remember about the differences, because they are really important. Okay. Imagine that this thing here is some kind of area of our memory, of our program. And right now it's free. When I do something like that, and I compile my program, I am reserving 4 bytes of memory, because I need 4 bytes for integer, right? Okay. And then, when I do something like that, I am reserving memory for a pointer somewhere. So for example, that place here. And then, when I do something like that, so I'm assign to P the address, I am doing something like that. So that guy here is pointing here. Okay. We can also assign the address in one line, right? Like that. So we can just comment that guy here and it will work also fine. As you can see, everything works fine. Okay. So as you can see, that thing, that notation, is giving the same result as that notation, right? Okay. So it means that we can change the value that is under the address just by using the pointer. Like that. For example, I will assign here now 20, and now I will send to the output the value of var, and then I will send to the output the value by using the asterisk and the pointer. Let's do something like that, so it will be easier to read. And you will notice after compiling that the value changed here, right? And we use the pointer to change that value. Great. We can also change the value by using, for example, still that guy. And you will notice that in both cases, both values were changed, because we are changing every time the value under the same address. Remember about it. Okay. Now you should notice that we can change where our pointer is pointing to. So for example, I can create another variable, for example a, and I will assign to it, for example, 20. And now I will do, for example, here, in that place here, I will do something like p now will equal to the address of a. So now that guy here is pointing to the address of variable a, not to the address of variable var. So now, when I use here asterisk, I will get the value that is under the address of variable a. And you'll notice that we have 20 now here. Okay? And again, now I can change the value here. And the value will change, and that instruction will change the value of that guy here. So I can send the output to see if it's working. And as you can see, the value changed like I told you, so I didn't lie. Okay, but sometimes we don't want to allow to change where our pointer is pointing to, where it is indicating to, right? When we don't want to allow something like that, we should create something what is called the constant pointer. In order to create a constant pointer, we should add here, in that place, the word constant. Now, we have to assign the address when we are creating a pointer, when we are defining it, and we won't be able to do something like that here. Now when I build it, as you can see, we can read here an error. Assignment of read-only variable. It means that we can't change here, something like that. But when the constant is here, we still can do something like changing the value that that pointer is pointing to. Okay? But we can't, of course, do something like that now. Okay. Let's maybe do something like that so you can read that later. For example, int p constant. Now I add also here the word constant. Now I will, for example, send it to a, and I will now comment it. This is a pointer that has to be initialized when defined, because it cannot change after defining it, after defining the thing that it is pointing to. So address, right? You can't change the address it's pointing to. Okay. We can also create something like that. Constant, int, and for example p2, and this time I can, for example, again send here, for example, address a, and this time we won't be able to change the value, because when we did it that way, you probably noticed that when we did it that way, we still could change the value here, right? We still could do something like that. But when I do something like that, I won't be able to change the value by using pointer. And sometimes it's really useful. Okay. So this is a pointer that cannot change the value that it is pointing to. Well, the value that is under address it is pointing to, right? But when we do something like that, we of course can change the address easy. We also can do something like that. Constant in and then again here, for example, constant, and this time this is a pointer that cannot change the value that is under address it is pointing to, and also it can't change the address. Okay? But don't worry, that things are not used very often if you don't understand it right now. The most important part of this lesson is that thing here, okay? Remember about it. And now we'll talk about something what it might confuse you a bit more, but don't worry. Well, look, that see here in our situation is our pointer, right? And as you can see, it is also somewhere in our memory. And it means that we also need a variable that could store address of our pointer. Yes, the pointer also has an address. Exactly. Wow, now it's getting a bit more confusing, right? Don't worry. Build and run. And now, let's do something like that. Integer, ordinary variable, right? And I will say to it, for example, that. Now I will create an ordinary pointer that will take the address of that guy here, right? And now I will send to the output the ordinary value var variable. And now I will send to the output the pointer. So this thing is address, right? As a result, that thing is integer value. And we also can send something like that. And this thing is what? This thing is integer value from pointed place. So in our situation, this ordinary variable, so it will be the same value as here. And now something new will send to the output the address of pointer itself, because it also has an address, right? Remember about it. Oh, and we can also send to the output the address of ordinary variable. And as you can see, ordinary variable is 10, the asterisk ordinary pointer is 10, so as I told you, everything is working fine. The address of ordinary variable is the same as address of ordinary pointer because they are pointing to the same place right now, right? And now, as you can see, the address of ordinary pointer is different because it has also address itself. Okay, so it means that we can create something that could store also address of a pointer. Yes, and this thing looks like that, integer. And now, we are creating now here two asterisk, and now we can call it, for example, a pointer pointing to address of pointer. Yes, I know it might be a bit confusing, and now I can do something like that, ordinary p, and when I do something like, let's send to the output, and let's see if that thing here is the same as that thing here. Let's see. As you can see, it's true. Now we can store the address of that guy here. And if I wanted to store the address of that guy here, because it also has an address, I would do something like that. But don't worry, situations like that are very, very, very rare. Okay? So, okay, that's all in that lesson. In next lessons, we'll talk about usage of that guys here. Yeah, I know it's confusing, don't worry. Thank you very much. Hello everybody, did you know that the name of an array is a pointer? Well, look, normally when we create, for example, an array that size is 3, and for example short int ZM, and now if we look into our memory, it would look probably like that. Of course, it could be in another place, and it would be, of course, bigger, but somewhere in our program, there would be 3 times reserved for bytes, for integer, because integer is reserving 4 bytes. And as you can see, after it we have the ZM, the shorting because it's reserving 2 bytes. It doesn't need to be next to each other, the ZM and the array, but they can be. And the most important thing here is that you should notice that array is always continuous. That means that they are next to each other, okay? So, it means that if we could point to that guy here, to that 0, we could jump 4 bytes later and we would meet the second element. And then again I could jump to 4 bytes later and I would meet the third element, right? Okay, now let's see how it's working. For example, I will send to the output right now the A here, and then I will send to the output the address of first element in an array. And as you can see, both addresses are the same. It means that this guy here is a pointer, right? Because if I did something like that, int pointer, now I will assign here address of first element, you would notice that by sending something like that to the output, we still have the same address here, right? So the name of the array is a pointer. And in addition to this, this pointer is also here constant. It means that we can't change, for example, the address here. So I had, for example, something like and now I would like to do something like that. No, we can't do that. We can't do something like that because it's constant, okay? We can't change the address here. Okay. Now let's send to the output all addresses of the array here. You will notice that they are moving by 4 bytes. So they are next to each other, right? 0, 4, 8 at the end here. If you had, for example, double here, I change here also double type, they are moving by 8 bytes, right? 0, 8, and then 2, 3 in that position. Okay, let's go back to the integer type. And now I'd like to show you something. Let's make some end lines here so it will be easier to read. And look, I will send to the output A, and then I will send to the output something like A plus 1, and then A plus 2. And as you can see, the values here are the same. 30, 33, 4, 38, and here are the same, right? So we can move here by using the pointer, by using the sign plus, right? The plus 1 here. And the plus 1 here doesn't mean that I want to move by 1 byte, but I want to move by 1 position of the size of that pointing variable that we point to right now, right? So in the for the integer, it means that we want to jump by 4, jump by 8. So it is like 2 multiplied by 4 here, something like that. Okay. Because pointers are intelligent, right? They know what they are pointing to, because it states here. So they know that if they meet something like +1, they have to jump by 4 bytes when it's integer. Okay. And now, what is cool, we could do something also like that. Because it's address, we can get value from that address by using the asterisk, right? Like I told you in last lesson. So I can do something like that easily. And now, we have here some random values because we didn't assign anything here. Let's assign here a few values. For example, 20 and 40. And as you can see, it's 0, 20, and 40. So we can do it that way. Or we can do it that way. So this notation is going to give the same result as this one. As you can see, everything works fine. Okay, I told you we can do something like that. Why? Because a++ is going to do the same thing like a equals a plus 1. So it means that I want to change the address of first element of that pointer here. And that pointer here, as I told you, is what? Constant. But, let's see, as you can, if you see, it's not working. But we can do easily another pointer, for example, integer, and let's call it, for example, p2, and assign here address of first element here in the array. And now we won't just type here constant, but we'll just remove that. We'll just do that, something like that. And now we can easily send to the output something like that. And then we can also do something, for example, like that, or like that, or like that. Okay, and all that pluses here in different positions means different things. If you don't understand the pre-incrementation, post-incrementation, please go to the arithmetic lesson, because it will be very important to understand it here. And now, what should we see as a result here? So here we are getting the value, we are retrieving the value that is under the address that is pointed here. So it will be what? 0, right? Okay. And then what we are doing? We are first incrementing the value that is under that address. So it means that here we will increase what? The value that is here, right? So it will be changed to 1. So here will be 0, here will be 1. And here we are doing what? We want to get the value from, and here we are doing something like let's move by 1 array later. So we are moving 4 bytes by 4 bytes here. Because pointer is intelligent, right? Like I told you. Now we are moving by 4 bytes. So here, move by 4 bytes and show me now here the address of next guy. Because we were pointing here at the first element. After that instruction here, we are going to point at second element, so that guy here. And we'll have here 20. Okay, what about that guy here? Here, I want the value from the current pointed address, right? So, right now it is 20. So we will send to the output 20. But after it, we are also increasing again, what? The address by 4 bytes. Because we are increasing address by 4 bytes. In next line, that guy here will be pointing to the address of that element of array. So we'll get here the value 40. Let's see if I'm not lying. As you can see, everything is working like I told you. 0, 1, 20, 20, 40. It might be a bit confusing at the beginning, but train a bit and it should be fine. Don't worry about it. So right now we are pointing to the last guy right here. We are pointing to the last guy of an array, but still we can jump. For example, we can do something like that later. As you can see now, I have here 2, and we can jump again. That values here after it are random. We don't know exactly what will be there. We are right now pointing on to the memory that might be used in our program, or it might be also something from another program. That's why we should be careful with pointers, because when we try to change something what is outside of our program, the variable that is used by other program, our program will stop running because it's not a secure operation and it will be stopped. Okay, that's all in that lesson. We'll talk about cooler things in next lesson that will use the informations in that lessons. Okay, that's all. Thank you very much. Hello everybody, today we are going to talk about dynamic allocation of memory. But first let's talk how it is done normally. Well, you know, when you write something like that, int array, and I will create an array of 100 elements, right? So 100 multiplied by 4 is 400 bytes. It means that when I click build and run, our compiler is reserving until our program ends 400 bytes of memory just for our program. Okay? And this is reserved for us. It cannot be used by other programs. Okay. And it means also that we can't, by typical defining like that, reserve more memory. We can't reserve, for example, after that, after compiling, after clicking that thing, when our program is running, more memory. But situations like that might happen a lot of times. It might be like when. Hey, imagine a situation like that. See out. How many numbers would you like to store in an array? So I'm asking our user, and I will take the amount he wants to store. For example, like that, to that variable, right? And now we probably would try to do something like that. What is very, very wrong thing. sorry, int amount. It's wrong thing, very wrong. When I do something like that, for example, I want to have 500 of that guys here. It means that I'm trying to right now get a value or change the value from the place which is free, or maybe it's not free. Because normally, I told you, when we did it that way, this thing happened when? Before compiling. And reserving memory like that is easy. But by doing it that way, we are trying to reserve something what is outside of our program space. And then we need special operators that can do that. Because right now when I do, for example, like that, it will compile. I can even send it to the output later. It's okay, everything is working. But, as you can see, everything works. But this thing that I assigned here, that value, could be assigned to the place, to the variable that is used in another program. And then our program would crash. Okay? Because that type of defining variable is not insuring us, is not making us sure about that memory will be free, okay? Well, our computer memory looks like that, for example. The red guys are reserved guys. A reserved space of memory, okay? The blue ones are not reserved. And now, you might be like, when we need that amount here multiplied by 4, we need that space in memory in a row. They must be one next to another one. They must be next to each other, right? Because that's how an array is working. Like I told you, when I do something like that a of 0, I want really something like that. And I want a of 1, I need something like that, right? The array is really a pointer, right? The name, the identifier of array is a pointer. Okay. So we might be now like, so how to do that? Okay, so this thing is wrong, of course. I've just deleted this guys here. And how to do that? We have something what is called new. That thing is telling to our PC that we need a free space in our memory after compiling. Remember, after compiling, not before. Whoa, okay. So we need it, and we want to be sure that it is free. We are just telling it to our PC just by using that guy here. And after it, we also need to tell our PC how many bytes of that memory we need. We can say, for example, I want 4 bytes of that memory. Or I can say, hey, I want, for example, 8 bytes of memory, right? Okay. So right now I'm telling, hey, I need 4 bytes of memory. And let's see if it is really an address. That guy here. Let's see. Let's send it to the output. As you can, maybe let's comment guys here first because it will just take our time. Let's build it. And as you can see, it's just an address. It's good. But look, isn't it at this address every time different? Oh, sorry, I just didn't run that guy. As you can see, every time the address is just different because we are allocating it dynamically. Okay? And can I get a value from the place? Yes, of course, we can get a value, but this might be a random value, right? Well, this is a random value because we have just got a free space in memory that could be used before by another program. But now it's ours, only ours. It cannot be used by other programs. Okay? Great. But now, hey, we have an address here, and what? We can send to the output the value that is under the address, or we can set the address itself. But, okay, I can also change the value here, but that's all. I'm changing the value, but the value here is again a new address that was just here reserved, right? So we don't have an identifier that we could refer to. So now you might be like, hey, but this is an address. It's an address, so I can store addresses. I can store them in pointers like that. I can do just something like that, and hey, I can store an address here, and I will be happy. Okay, now I'm storing address in a pointer. So I can send to the output the value that is there. I can also change that value, for example, to 50. Great. Okay, and now I would like to tell you about something very important. When I do something like a local variable, so local variables, I'm reminding you, are being destroyed after meeting the curly closing bracket. That thing here is called static local space, something like that. We could do just something like that. If 50, then it's that. That thing will work without even checking the condition here. So this variable after that curly bracket is not going to be anymore in our program, right? As you can see, our compiler is telling us that P is undeclared because after the curly bracket we can't get anything from that pointer here. So it also means that we reserved here a memory, and this memory, like I told you, belongs only to who? To our program. To us, right? And because of that, it's not free anymore. It will be always belonging to us, okay? So we have to do something with that. We have to free that guy, that space. We have to release that space in memory. In order to do it, we can use a word delete, and then we have to give an address of a place where, that wants to be released by us. So we want to release the place that is pointed by that pointer here. And now we are sure, we are happy that this memory is free and it can be used by other guys later. But remember that this delete here doesn't mean that I am deleting the pointer. It is just releasing that address here. So it means that I can send after it the pointer, for example like that, to the output, and as you can see every time that address is the same. The addresses are the same still because he's still pointing to that place. But this place is not belonging to us anymore. It's not belonging to us. Because it's not belonging to us, we shouldn't change that value there because it's wrong. So when I do something like that here, of course, yeah, it will happen. I will change the value. But right now I'm changing value of a place that I shouldn't change. So, oh, that's bad thing here. As you can see, it's random value after deleting, right? Again, it can be used by other programs. So when we delete the space, we should always also assign here null. Null is just the empty space in our memory, something like 0, okay? And now, when I do something like, for example, if p exists, so if p is not equal to null, then I can do, for example, things like that. I can do that then. Then everything is fine. But otherwise, please just don't do that things here. Okay? So, if I do it that way, everything will work fine. And it's okay. But I should do it that way when I delete the pointer. Okay? We should also know that after deleting, that pointer here can store another address of another variable. So for example, that guy here, let's assign another value here. I can do something like, hey, okay, now I want to store the address of variable here. And now I can build and run that program. As you can see, I changed that value here also. Look, I can send it to the output here. It's changed. It's okay, everything is working fine. Great. But remember that this operation here is not dynamically reserving of memory, so I don't need to delete that guy here again, right? I don't need to free that memory. I need to free only memory that is reserved dynamically. This is just typical association. Okay? Okay, now let's go back to our problem at the beginning of our program. So let's comment that guys here. And now let's do the program that we wanted to do at the beginning. So how many numbers would you like to store in an array? I would like to store, for example, 500 of elements. So int, and now I will store it in a pointer, equals new int, and here I can also, in the square bracket, tell our PC how many times multiplied by the type I want to have bytes, right? So, for example, I will type here 5, so 5 multiplied by 4 means 20, so I want 20 bytes in memory. And the new here operator will return the beginning of that space that was just here reserved. So it will return the address. P will store that address. We can send it to the output, so we can see that. So for example 5, as you can see, here we have an address that is stored. As you can see, that the addresses are different, right? They are different every time. Okay. So let's also remember about that I have to delete the space that is reserved by that pointer at the end of the program. Remember always about that. And now we can do, for example, for int I, when I is lower than amount, I++. And let's send to the output cout. Enter the and let's send to the output which guy. So I plus 1, because here is 0, so 1 0 plus 1 is 1, and number, and then colon, end line, and let's take that guy here, because you know we can use that thing here easy, because as I told you, the point when I did something like that, for example, array is really a pointer, right? So array plus 1 is the same like array of 1, and here I have just a pointer to the first element of address, so everything is working fine. And then I can send to the output that values that we just typed here, so I can just send to the output the p of I equals p of I. Now let's compile it, and I will type, for example, 5 numbers: 10, 40, 50, 500, and as you can see, everything is working fine. Great. Okay, but what will happen when I do something like that? I want to reserve that much of memory. This application has requested the runtime terminated in an unusual way, and because, well, we can't get so much memory, right? So we could here try to catch that error, but we'll talk about catching errors in other lessons. We can do something like that. No throw, so it means that we are not going to catch anything because we don't know how to do that. And if we don't have enough space, here to that pointer will be assigned a null. So we can do something like, if p is not equal to null, then please just do the things here, right? But otherwise, say to our user that we don't have enough memory. So I will now do something like that, and as you can see, our program is at least working properly. So we could do after it other instructions, right? Okay. And now I'd like to tell you something very interesting. Let's comment that, guys, here as a training. Let's go back to that code here and look at that thing. Oh, let's just comment that, guys, here. Okay. Let's do something like that. We are now reserving that 4 bytes, right? And we are sending to the output the just our address that's been just reserved, and we can see it's like, for example, 68 at the end, right? And what if I do something like that? Delete, then p, and I will do something like that, and then again that. As you can see, both times we reserve the same space in memory, because our program remembered that we can store in that place 4 bytes. If I did something like that, it would be a bit different, as you can see from that guy here. But look, now it's the same, but when I don't delete that guy here, as you can see, they are different. Why they are different? Because this thing that was reserved for our program, only for our program, is not free. We haven't released that guy. So we can't take that space in memory anymore. I'm just telling you that so you notice that we have to remember about that damn releasing of memory. At the beginning, it might be for you a bit confusing why to do it. Really, it can make so many errors. Remember about it. It may kill your program. It might buggy, which means you have many errors. Ah, okay, that's all in that lesson. Thank you very much. Hello everybody. Today I want to tell you about strings and characters. Well, exactly, I want to focus on the pointer that points on the character type. And before we do something like that, let's remind what are strings and other things like that. Well, I want to create a string, so I type string, then the name of our string, so for example text, and then I can assign here some characters. So for example, tra-la-la-la-la, right? So I'm singing here. Okay, and now how to get that characters here? Well, we can do, for example, a loop like that. When I is lower than text dot length, that length will return here. It is a function to return the length of that guy here. So it is, let's make it a bit shorter. 1, 2, 3, 4, 5. Well, the truth is that it is 6 character long. There is one more character. I will talk about it later. But right now, you should know that the length function will return here how many characters are in the string. 1, 2, 3, 4, 5. How many visible one, okay? Of course, there is one more character, and we'll talk about it later. Now the I++, because we have to increase the I, so the condition will be finally, not through someday, and then let's send to the output the text of I and then end line. And as you can see, we can send each letter to the output. So it means that that string is really an array of characters, right? One character, second character, third, fourth, fifth character, right? Okay. Of course, because that are characters, we can assign single character to the variable that type is char, right? So character, and now, for example, something like that. We can do that easy, and we can send it to the output. Let's build and run that, and as you can see, everything is working fine. There is a T at the end here. It's okay. Okay, let's comment that guys here because we won't need them. I told you that this guy is 1, 2, 3, 4, 5, 6 letters of length here, right? And why? Because this is saved like that. T, R, A, L, A, and then there is something which is called the \0. Because when we want to send to the output a string, so the sequence of character, we are sending everything to the output until we meet that guy here, the that \0, the 0 character, right? And then it just stops sending to the output thing. So it's really important to have something like that. Okay. Now, how to, we are right now programming in C++. Before, when there wasn't C++, so there wasn't something like a string, there were only characters. Then we had to store characters in the array of characters. Well, this is an array of characters here, right? As you have noticed here. So, but it is hidden inside the string a bit. Well, let's see how it's hidden. Well, first, I can do something like that. For example, characters, and then I will give here the size of 5, and now I can assign here 5 characters. For example, 1, 2, 3, 4, 5, right? Well, no, this is 5 characters, because we need to remember that the 5th guy need to be the backslash 0, right? Okay. So now we can send to the output characters. Sorry. And as you can see, everything works fine. So that's how people start strings. But there are many problems that will be soon shown here. What if I want to change now that guy to, for example, something like that? This is a bit longer than this, right? And I want to send it to the output. As you can see here, we are being said that I want to assign 25 characters to the place where we can store only 5 of them. We can do that. Here, I can do it easy. Let's see. As if you can see, everything works fine. Because behind there is a program that is doing it by us. Well, we are programming in C++, so we shouldn't worry about the characters here and doing the things like that. But, you know, you might want to look into libraries from C, and then you would not understand what is in there. So that's why we have to now focus on how to do that, how to do things like that with just characters like here. Well, firstly, we don't need to here type the 5. Our compiler is so intelligent that when he see that I want to send here something like that, the sequence of character, he will give here the right size for that array. Okay, so that's okay. And now you know from lessons from the previous lessons that this guy here, characters, is really a pointer, right? It's a pointer. Characters. So it means that this guy is really pointing at the beginning to that guy here, to the first letter. Okay. So we can send the output that thing that way, the first character, or we can send it to the output that way. Does everything okay? As you can see, both times we got 1, 1 here. And if I want to have the next letter, I can just do it, for example, that way. It also means that I can do something like that. Character, and now let's create a pointer that will point to the address that is pointed by that guy here. So to the first letter here. And then I can do something like that again, for example. But now I can do that with P, and everything should work fine. As you can see, 1, 1, 2, 2, 1, 1, 2, 2. So that guy will do the same things like that. And now it might be like, how to transfer that guy here from string to characters. How to do that? Is it possible? Let's see. Can I do something like that? Char characters, something like text2 equals, well, that way, that text here. Can I do that? As you can see, we can do something like that. Because here we have an arrow that says us initializer, so the guy here, phase, so he is not able to do that, to determine size of text2. so he doesn't know how much of that thing he put here, right? And when I put something here, it says that it's invalid initializer. It's because the text is string, and we want to assign string, so a different type, to characters, well, to array of characters, and we can do something like that. Well, but let's try to do it this time that way. And what will happen now? Now our Ben said that we cannot convert the string to the character asterisk, so to the pointer to characters. But in string, there is a method that allows us to do something like change the string here to that type here. So this thing will return us the pointer to the first letter here. Let's see. As you can see, still we can't do that because it is returning the constant. So it's returning it that way that we can't change later letters in by using that pointer here. Let's check it out. If we can at least send to the output values. Well, let's comment the guys here because we don't need them now. So I want to send to the output, but then this is a test. Something like that. As you can see, this is a test and everything works fine. So now we know how to change string to characters. Okay, how to do that the other way? So I have, for example, the array of some elements, and here is text. And now can I do something like string test, and can I send him array and now send to the output test? As you can see, this way everything works fine. So there are so many problems like to the library of C if you want to do something like that. Okay. Now I'd like to tell you about something what might be a bit weird for you, because we can do something like character and then, for example, a equals this is a test. So let's make it different test. So now we can send easily to the output A. As you can see, this is a test and this big number here. But we can't change values here. We can't do something like that. It's not possible. It won't work because our program will stop working. And why it's happening like that? Because this guy here is being created when we are compiling the program as a static string. It means that it has a word constant, right? So it means that we can't change values. Okay. And here we have just an in that a point. Well, we have an address to the first letter here, but this letter cannot be changed. So we can send to the output all that values easy, but we can't change the values here. Okay. So in order to prevent errors, we should add here constant. We don't need to, but we should add here something like that. And then we won't do something like by mistake, because our compiler will tell us, hey, you can do that. Okay. But it's very confusing because, we can do something like that easy. This is a test, And then, oh sorry, the brackets are here, brackets. And I can send to the output beam, but I also can do something like beam and then change the value, for example, the first to the G. I can do that. And you might be now like, but why? You know, our compiler is thinking like that. When he sees that guy here, he is reserving the space for a pointer. And then he is assigning to the value of a pointer, is assigning the first address of that sequence of characters. When he sees something like that, he is reserving space in memory for so many letters like here, so he's counting them, and then he's assigning to all of that reserved space in memory that letters. So that's a bit different here, right? This is somewhere in our space, we don't know exactly where but it is pointed by that guy and it is constant. But this guy is not a constant guy. Okay? We can also do something like that. Character, and then we can, for example, create now the dynamic array, for example, like that. And now here equals and new character, and we need, for example, 50 of characters. Now I will delete at the end of the program reserved space just in case I do not remember about it later. So now it's done instantly. Okay, and I can easily assign here or send it to the output first. Let's see what's there. So we're sending it to the output. As you can see, here are random characters because, of course, that guys here are reserved dynamically, right? So we have to assign here something. We can do it that way, for example, la la la, and everything will work fine. But we should notice one thing. After assigning to that guy here that static value here, because it's a static guy, so it's constant, this is constant value, we can't change values inside like that anymore. As you can see, it's not working. But look, before that, we can do it easy. This is working. But it's because we changed it here. And we also made a big error by doing that line here. Because we, after that, are not able to delete that space here that was just dynamically reserved. So be careful on doing something like that. We can't do things like that. We should add here also a word constant. So by mistake, we do not change here the address that we are pointing to. Okay? So now everything works fine. We should also somewhere end this, for example, with the black star 0. Well, as you can see, in the C, that was a bit harder to create characters. You can just use string, so don't worry. I'd also tell you that when you create an array of strings, so for example string, array of strings, and now, for example, 5 of them, and I can assign to all of the strings, so to all the sequence here, some text. This is a text that will be in all of the elements of strings. And now I can send to the output something like that. As you can see, now all strings are like that. Of course, I can change here easy that guys to other guy, and we don't have to worry about memory like I told you before. But I told you all about the things here because really it might happen in the future that you want to read something from the C library, because still some people need to use them, or you need to write something in C. Then that information here should be really useful for you. Okay, that's all in the lesson. Thank you very much. Hello everybody, today we are going to train pointers. Today we are going to see how useful pointers are. Okay, so we will start this lesson from example like that. When I have a variable, for example int a, and I will assign to that variable value 10, and I want to change value under the address here, so in this variable, in another function, I have to use the reference or pointers. Let's remind the version with the reference. I had to do something like void multiply by, then what are arguments in our function. So the first argument is the reference, and the second argument is by what amount we want to multiply by. Then, after creating the prototype of function, so after declaration of function, we should create a definition of function, so the body of it. And now, here we have the variable that we want to multiply by something, and here is the amount that we want to multiply by that guy. Because this is a reference, it looks like the definition and initialization looks like that, equals here the 8, and now the var is just the nickname for a, right? And because of that, now when I, for example, do something like that, I am changing the value also here, right? So now when I send to the output a, after of course changing it by that function here, for example, let's multiply 10 by 5, we should see here as a result, oops, of course, a, we should see as a result 15. Okay, everything works fine. What about if I wanted to do that thing by using the pointers? It would look like that. Here I am taking the pointer right now. Of course, here I'm changing it also. And now I should use here that asterisk, right? Because a pointer is what? Pointer is a variable that can store an address of type that it is pointing to. So that pointer here can store an address of the variable that is integer, right? So right now we are sending the a here. Well, we shouldn't send an a here as a value, because we should send here what? An address, because we want to store an address here. So I'm sending here right now an address of a, right? And here it would look like that, something like that. And now we have an address in that guy, and with the asterisk here we can get the value from that address, right? Well, let's maybe do it that way. It will look a bit easier, right? And now let's see, it's working. As you can see, the value is again 50, so everything works fine. So I'm reminding you that we have to send an address here when we are taking the when we are declaring here as a parameter the pointer, right? Okay, now I'd like to also tell you how to return pointers. Well, if I do something like that, and now I will return here something like that, I am returning only value. So if I do here int b, and then I will send b to the output here, I should have 50 and 50, right? Everything is okay, but this guy here right now is totally different variable. Now when I send here, for example, 999, you will notice that we changed the value of b, but we didn't change the value of a. If I want to return the pointer, I have to add here also an asterisk. Of course, it can be here, it can be here, it can be here. Don't worry, this is just white space, they are not interpreted. But, well, I prefer the notation like that. And now, look, I won't be able to compile it because here we should return what? A pointer. So we are returning a pointer and we are trying to assign it to the guy that can store pointers. Right now, when I change it to the asterisk here, I can store it easily. And of course, now we should change the value that way. And we should also return a pointer. So we're not returning a value, but the address, right? And now let's see. As you can see, of course, here like that. As you can see, now I change the value here and also here, okay? So that's how you can return a pointer. Okay, that thing, if we could only do that things with pointers, you wouldn't be happy now because you would be like, hey, I lost lots of time. I could do that things almost with reference, right? Almost everything like that. Yes, but look, right now, because of pointers, we can send to functions arrays. Before we couldn't do that. Because arrays always are in our memory stored that way that they are next to each other, right? And because of pointers, because they are storing address, the first address of first element in an array, we can jump one by one element, right? Because they are next to each other. And we can just send the first guy and then we can jump to the next guy, and I'm sure that this will be my value in an array somewhere, right? Okay, so let's create an array. So int array, and let's make size here 10. Let's assign here 0 at the beginning, or maybe we don't need to do it that way. Let's just assign value to all of the guys here. So let's do something like that. Array of I equals, and let's assign just I here, and let's send to the output so you can see how does it look like right now. And let's compile it, and as you can see, so we have 0, 1, 2 to 9. We can send it that way so it will be easier to read later and debug our program, right? So to check if there are any bugs. As you can see now, everything is working fine, okay? And well, let's create a function that will be able to change, well, will multiply our array by some kind of value. So multiply by multiply array by, and here, for example, I will create two parameters, int, and now it will be the pointer here, right? We'll send an array here because name of array, so that guy here, array, is really a pointer, right? So we can send it here like that. And then we have to also send, of course, the amount that we want to multiply that guys by. Oops, I didn't copy that. Now everything is okay. So let's name that, guys, array, and here I will type amount. Okay, so well, we want to multiply that, guys. I would like to also add, you can send arrays that way also. That way is okay too. So you can send array that way. Well, let's do that. For example, multiply array by, let's send the array, and then for example by 5, right? As you can see, everything is working, and we can do it, of course, that way. So both ways are okay. Okay, and now how to change values. So for example, let's create a loop when I is lower than 10, then I plus plus, and then we should just do array of I equals array of I multiplied by amount, right? And now we can send it to the output. Let's go on that guy here, and we should just see everything multiplied by 5 in that array. So everything works fine. As you can see, now we can send easily arrays to functions. But hey, you might be like, oh, why are you typing the 10 here? Isn't it too easy? Yes, it's really too easy right now, and it is very bad idea to do that way. Because I can change it right now here to, for example, 16. Well, I would have to change here and here that amount. And well, I could do it as a constant. This is a good idea, but it's not still the best idea, because for example, what about situations when we are dynamically creating arrays? Then we should check the size of arrays. For example, how to check the size of that array here. Let's send to the output something like cout size of, and then name of array. Let's make a few let's just comment that here, and what we'll see, build an array. As you can see, it's 240. Why is it so? Well, let's make it a bit lower value. For 10 it is 40, because 10 multiplied by 4 is 40. So this function is returning us how many bytes are stored in memory for an array like that. When I do something like size of integer, you'll notice that now here is 4. So this is giving us the size of integer. When I do something like that, it will give us the size of one of element in that array. I think this version is the best, because we might also change this guy to double later, and then here also it will change other things. You have to, of course, change also function, but well, you know what. Okay, so this is really better idea to use something like that here. And now we can, of course, do also something like that. Size of our array divided by the size of type that is right now here will just give us the size of array. So it is 10, right? And now we can just use it. Now we can just change it here, and it will work fine, as you can see. But there is a problem. When I do something like it here, so when I check the size of the pointer, not an array, here is a pointer. Here we have an array that was created by us, and here we can check the size like that way. But here, look what will be what value we will see. It is 4, as you can see, so it's wrong. because of that, unluckily in C++ we have to send the size of array to the function. So we have to send it here that way. And now, of course, let's change it here. We can, of course, make it that way also. And now, let's see if it's working. Let's change the prototype also. So the declaration function. And now, as you can see, everything works fine too. Now let's train a bit. So for example, let's change the loop to something like while the size of array minus minus. So until we see here the 0, please execute the instruction below. Size of array amount. Let's see if it's working. As you can see, it works too. Okay, and now how it works? Well, we are sending the size of array here, so 10. So we have in size of array 10, and then here is a post the decrementation. So we are decrementing it after checking the condition. So if 10 it is true, then we are decreasing it to now, and we are changing the value that is under the array of 9, and we are just multiplying it by that amount. So that's how it works, right? Until this guy here is just 0. Okay, I would like to also add now that you should notice that this guy here, right, that array, is being set that way, not that way that we are sending the address here. Because remember, if I did it that way here, I would send the address of a pointer, not the value that is stored in a pointer. I know that the pointer is also storing the address, but it is address of something else, right? It is not address of a pointer, but it is address of something that under it we can find a value, right? For example, like that, okay? A value that is double, that is float, or something like that, for example. Okay, and so it means that we can send here it that way. So we are sending it here the first element. Everything will still works fine, and I'm telling you now that array of 0 equals the name of our array, right? Because it is really a pointer. Okay, that's all in that lesson. Thank you very much. Hello everybody, today we are going to learn how to create a pseudo-random numbers generator. So we are going to learn how to draw numbers from some kind of set. Okay, so how to do that? Well, we can create, for example, a variable that we stored random number, so for example integer number, and then I will assign here the result from the function that is called random. Then I will send this thing to the output, and let's see what that output is. It is 41. Okay, so let's compile it again, and as you can see it's again 41. Let's compile it again, as you can see it is 41. Wow, so great, it is really a random number, right? No, this thing is called pseudo-random. Remember, well, you know, what is the difference between the pseudo-random number and the random number? Imagine, right now I'm having a cube in my hand and I am throwing it. I might throw it with a bigger strength or lower strength, right? And every time that cube can meet different obstacles on the way, right? And then this is a random number, totally random, because we don't know how exactly it will react with the environment around, okay? But the pseudo-random, so the pseudo-random number is going always, it is following some rules, okay? It is following rules because it is computer. Right now he can't throw cube and he will not meet the same obstacles, the random obstacles, and he doesn't have strength and other things like that, okay? So he is following some rules always. Okay, so this is pseudo-randoms, and we can send the rules for that function here by using the function that is called the srand. Here in that here we can send the rule how that function will be working. Okay, this s is here stands here for seat. Seats. This is just a set of values that we will get random values from, right? So I type here now 400, and you'll notice that this number is new now, right? And now I'll build it again. As you can see, it is still the same, but this is not now the 41. So it means that for 41, here was different number. Now we change it to different number. Okay, let's see what will happen when we do something like that. As you can see, now we have 3 different numbers. So every time we have different number, and it's cool. But hey, every time I run the program, the number is the same. But when I change that thing here to something else, the numbers are being changed then, right? They are different. Then it's cool. So it means that we need something here that would change every time I execute the program. Tell me, what thing in our world is changing every second? Well, I just told you. It is time. Look, we can send to the output something, the result of the function that is called time. And here we can send as an argument null, because this function is taking as a parameter a pointer. I don't want to go into this detail of that function, but well, remember that this function is giving us as a result how many seconds are gone from 1090 or something like that. Well, it doesn't matter. The most important thing about that function is that the seconds every time will be here different. As you can see at the end we have 26, and now a few seconds later we have now here 32, right? So it is changing. This is the most important part in that thing. Now when I do it that way, you will notice that every time I run the program, that numbers all will be different. Great, cool. So now we know how to have always pseudo-random numbers. That's okay. So now let's create a function that will represent the lottery, okay? That function will be called lottery, and it will not return anything right now. And we will take 2 parameters here, 2 integers. The first one, let's specify that function here, will be how many numbers we will draw from, right? How many numbers we'll have in our set. So for example 49, and as a second we will have, well, maybe we can do it that way, for example total balls, and here I will call it balls to draw or balls to allot. That are the same words, okay? And now we can create that function. It's like we'll use it later like that. and we'll send here, for example, 49 here 6, and I want to have send to the output after that, invoking of that function, 6 numbers from 49, and I want them to be all random, right? Pseudo-random way. And first thing we should check what? We should check if the total balls is lower than balls to draw. Why? Well, because we can't do something like that, right? We can't get 1235 numbers from 49 and to make them all different, right? That can't happen. That's impossible. So we should check it, and then if the total balls is lower than balls to draw, we should just return. When I told you that we can't return anything, when here we are returning the void, because it is the empty. As you can see, we are returning nothing. We don't have anything after the return one. And this thing means that we are just leaving that function. So every instruction after that here won't be executed at all. Okay, so now we should also create a seed, right? So like that. Okay, and now we will create dynamically, because that thing here can be changed every second, array. So we will now create a pointer that we call balls, and we will assign here by using the new operator. So the new operator will return here the address for integer, and the first address of integer array. That size will be balls to draw, right? So we'll store here the balls that will be drawn in that function, and I should delete that balls at the end of the function, right? Well, I should delete by saying deleting, I mean that I am freeing the memory that was dynamically reserved here, right? Remember about it. This is very important to do it here. Okay, so now we should just get that random number. So for int I equals 0 when I is lower than balls to draw, I plus plus. And now we should just assign to balls of I something, for example, random number. And now, well, we need numbers that are in range from 1 to 49. And soon I will tell you how to do that things. And let's send that thing to the output. So let's see the result. Let's just send it to the output right now. As you can see, we have now numbers. We have now 6 numbers that are random, but we need them, of course, to be from that range here. Okay, and here we will use something what is called the modulo operator. Right, we're coming back to the first lesson, and here, when I do something like that, look what will happen. As a result, we have now numbers from 0 to 48. Well, maybe let's train this thing a bit. Here, int number, random, modulo, for example, 3, and now then send to the output that number. Let's do it that way. And also the seed, and let's send it to the output. As you can see, this thing was 1, now it's 2, and I will beat it again, and then it's 0, and then it is 1, and then it is 2, and again it will be 0, because that's how the modulo operator is working, right? It is giving us the reminder of that value here. If you don't remember how this operator works, please go back to the 6th lesson, I think, the arithmetic lesson, and you will see how that operator works. It's really important to understand it. So now, by doing something like it, we have the set of numbers like that. But I want to have 49 of that guys, right? So by doing something like that, oops, the comment, I will have numbers from 0 to 48, right? That way. If I want to have from 1 to 49, I should just add after it just 1, right? And then I will have numbers from 1 to 49, that way. Okay, so let's use the information that we've just seen here, and let's just do it that way here. As you and of course, let's do it that way. And as you can see, now we have pseudo-random numbers. Hey, but this guy is repeated here. They're the same. We can't do something like that. We want to have, well, the most time in the lottery, we want all numbers to be different. When I do something like that, 6 from 6, as you can see, well, of course, here is not 49, but we should change that guy here to total balls. As you can see, the numbers sometimes will be repeated, and we don't want situations like that. We want all numbers to be different. And now the true hard thing will start. Okay, so how to do that? We should just check all the numbers that have already been drawn, right? And if there is a ball like that in that set, it means that we should again repeat the drawing of numbers, right? Okay, so let's create an inner function here that will be invoking the instruction how many times? When g is lower than I, because I will represent how many balls we have already drawn, right? Then g++, and we can now check all balls one by one. Okay, so how to do that? We can do something like that. If balls of I equals balls of G, right? It means that we should just decrement the I, and because of that, we'll just repeat the drawing of number to that array. And we can break after that easily, because we know that if one guy is repeated, we don't need to check other balls, right? But we also should notice that the G might be here once equal to I, right? Because they might be equal here, we will check the equality of two the same balls. We will check something like, is balls of 0 equals to balls of 0? It might happen, something like that might happen, and of course this is true, and then this loop will start being the infinite loop, right? So we should check here by using the conjunction if the I is not equal in the same time to G. So if they are equal here, we won't just check if they check the equality of values in that arrays. Okay. Now, and otherwise we'll just send to the output, well, else if the G is equals I. So if we end that loop here, it means that the ball here that was drawn for sure wasn't repeated value, so we can send it to the output easy for example, here, balls of I, right? And line. And now, what will happen? As you can see, nothing. That's because this thing here needs also here something like I plus 1. Now, all the values here will be always different. So, I'm changing it to 49, and now I have 6 numbers from 49, they're all different. But why do I need the plus 1 here? Because I told you once that the condition in for loop is checked at the start, at the beginning, okay? So if it's checked at the beginning, we have to remember that the I at the beginning here was 0, and we are checking if 0 was lower than 0. And then the condition was just false, right? And that loop wasn't executed at all, and we couldn't send that thing here to the output, right? Okay. And now everything works fine. It's okay, right? Cool. Okay, that's all in the lesson. Thank you very much. Hello everybody. Today we are going to talk about typecasting. Typecasting means that we can convert one variable of one type to another type. Okay, so it means that, for example, I have double value 5.5, right? And now I'm sending it to the output. As you can see, the output is right. But what if I wanted to change the double to int? I would use the typecasting here, the explicit one, okay? So it means that we have to tell about it. I will use the parentheses, and in parentheses I will type the type that I want to cast to the variable after it. So I want to cast var to the integer. And as you can see, we lost the value after the dot, right? Okay, but hey, this was bad thing, right? Because we lost the value after the dot, right? But sometimes something like that is useful. For example, I have variable like that and variable like that, and I want to divide a by b. Now, as you can see, the result is 0 because both variables here are what? Are integers, right? And now I can change one of them to, for example, double, and because of that the result will be right. Because if that guy is double, that variable is being converted, is being casted implicit. Okay, so we can cast the explicit way. So the explicit way is like, for example, that. This is the explicit way. Or we can do something like that. For example, I want to create two variables, x and short y, that will take x here. As you can see, we can build that program, everything works fine. But you know that x can store a bit bigger values, right, than the short one. And we can lose here that some digits. As you can see, we are allowed to assign that variable to here, but the result is wrong. Okay, so we should be careful that thing can happen easily. This is the implicit way of casting, so we don't have to specify it in parentheses. But be careful, because we can lose precision, right? Or we can lose even old number by doing things like that. Okay, so I want to tell you about all explicit ways now. The explicit way can look also like that. So we can use it like a function. It will work fine also, as you can see, 5 at the end. And we can use something like that: static cast, and then in the angle brackets the type that I want to cast to, explicit way in C++. This is the C version, and this is also C version. Sorry, static, of course. And as you can see, it works also fine. And where maybe it would be more useful, later we'll know something like class and other things like that, and then things like that will be more useful for sure. But for now, for example, we can check what value in the ASCII table character is. For example, character, and now I can type here key, and I can send to the output it that way. But I can also change it to the integer type, and as you can see, it's 107. Let's check if it's true. As you can see, the key is at 107. So we can easily check the value, the true value of character, for example. It might be useful because sometimes you have characters that are only in your country. For example, in my country I have a character like that. I can see that this character is assigned to -91, and because of that I will know how to check that characters, right? They are not in the ASCII table, because here I have values from 0 to 127, and that character was on minus side. Okay, that's all in the lesson. Thank you very much.